Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore a very interesting project, and that is cost effective document classification using Amazon Titan Multimodal Embedding model. Okay, so how to perform image classification using Amazon Titan Multimodal Embedding and Pinecone vector database, on that I have already explained in detail in my previous video. So please go through that particular prerequisite video. The link I'll be providing in the description box or in the comment section as well, because that particular concept will surely help you to understand today's project in a detailed way. Okay, so first let us try to understand what is the business problem or what we are trying to solve, and then we will go through a demo of our project, and then we will explore how we have implemented the project. Okay, so suppose let's consider here we are having one S3 landing layer. I can call it input S3 location. Here varieties of documents are getting landed from different sources. Some can be email images, okay, it can be invoices, it can be bank statement, it can be social security card, etc, etc. So varieties of images are getting landed in our input S3 location, and for all these different category of images we are having different downstream pipelines. One pipeline handle the email image processing, one pipeline handle the invoice image processing, one pipeline handle the bank statement related image processing, another pipeline handle the social security card related image processing. Okay, so here what we have to do, currently manually we are segregating the images into different locations. So let's consider we are having another S3 location. So here we can give the location name as classified S3 location. Okay, here what is happening, from this input S3 location where all the different kind of images are getting landed all together, here manually we are segregating into different S3 location. So for all these 4 different classes, 4 different locations got created. One will contain the email, one will contain the invoices, one will contain the bank statement, one will contain the social security card. And once the different classes of images get landed in this classified S3 location, then these downstream jobs which are specific to one particular class will start processing the particular category of images. Like that way currently the pipeline is created. Okay, now here in this particular layer, classifying one particular image and putting it in a particular location, that is done manually. Let's consider we want to automate that particular process, right? So how to do that using generative AI models, that we are going to explore in this particular video. And that's what here it is defined, that document classification using Amazon Titan Multimodal Embedding model, right? So I hope the problem statement we understood. Now without any further delay, let me quickly show you one demo of this project so that we will get a better sense out of it, that what we are trying to solve basically, right? So here let me show you some samples. So here if you observe, I have taken some test images. Let me open one image, and here this particular image name is test1.png. As you can clearly understand, this is nothing but a bank statement. Okay, right? Then next image let me open. This is another category of our document class, that is closing disclosure, right? The next image let's open. It is nothing but kind of email, right? And then next image let me open, and this is one social security card. And here we are having a different class of image, that is W4 form, right? And then here let's consider this image. This is kind of an invoice, right? So let's consider all these different categories of images we basically process in our data pipeline, and all these images are getting landed in one common S3 location, that is this particular bucket, landing bucket location. Okay, what we need to do, we need to segregate these images into different folders within this particular bucket, that is classified bucket using LLM. And here for closing disclosure, one folder should be there where all the closing disclosure related images will be going. One particular folder related to email will be there. Whenever in our landing bucket some email images will be getting landed, it should be getting ingested in that email folder. Same goes for social security card, same goes for invoice images. If some images related to invoice lands in this particular bucket, here in a specific invoice folder, that particular image should be sent, right? So that way, where currently the classification or the segregation we are doing manually, that we want to automate using LLM and AWS services, right? So let me show you that particular implementation. So here we are having one bank statement image. All I will do, let's upload in our input S3 location. So here it is 14.6 MB. Depending on internet speed, it is going to take some time. Let's wait for that. And here if you see, the test1.png is having category of bank account statement kind of thing, right? So automatically what will happen, once the image will be uploaded, our automated multimodal image classifier pipeline should detect the class of this particular image as bank account statement, and in this particular output S3 bucket, one particular folder related to bank statement should be created, and there this particular image should be copied, and we no longer need this particular image in this particular landing location that time once the image is copied, right? So the image should be deleted from here as well. So we'll explore that. So here the image is uploaded. If I refresh, let's see, and here you can see the image got deleted. So here we can assume that in our output location the image should be properly classified in a bank account statement folder. So if I refresh our output directory, here you can see bank statement folder, and within that if we go, our test1.png image is available. I can download and show you that the image is same image what we have uploaded. So here you can see the image is getting downloaded, and here if I open, here you can see that the downloaded image test1.png is same what we have uploaded just now, right? So what I am trying to say is, in this process automatic image classification is happening. Like for example, here I can take up another image that is closing disclosure, right? So let me upload that particular image here. So test2.jpg, and our automatic data pipeline should detect the class of the uploaded image as closing disclosure type, and here it should be creating the folder for that. So here this is our output bucket, and if I refresh, here you can see closing disclosure folder got created where test2.jpg just now what we have uploaded is copied, and here in our landing directory we no longer need that test2.jpg, so that's why it got deleted from landing location. I can download and show you again that this image is the same what we have uploaded, like here test2.jpg, this is closing disclosure category, and what is got copied, that is the same image closing disclosure, right? And following that same pattern, I can show you some couple of more example. Like here you can see this is of email category, so I'll upload this, and let's see in our output bucket what should happen. One email category folder should be created where this particular image should be copied, right? So here our email image is uploaded, and that got deleted also. If I refresh, here you can see in near real time the image classification to different categories is happening, and in the respective output folder the images are going, like test3.tif, whatever we uploaded that went, right? Maybe I can show you another example. Let's consider this particular image. This is again another bank statement. So here if we upload this test8 image and upload it, what should happen? Now no new folder should be created because already we are having a bank statement, there the image should be copied, and you can see just now the image is copied also, because here the image was uploaded, our pipeline got triggered in real time, and here test8.png got copied in bank statement folder, because here the test8 image is of bank statement category, bank account statement category, right? So here I hope you can clearly understand, in real time the image classification is happening and we no need manual intervention, right? And once the image get landed in the respective folder within our output directory, from there the dedicated pipeline related to bank statement processing or closing disclosure processing or email processing, which are specific to one particular folder category or specific to one particular class, that particular pipeline can be triggered, and those pipelines can process these images respectively, right? So I hope the business problem and what we tried to solve, that is clear to you. Now we will jump into the actual project, that how we have implemented this particular process, right? So we will catch up in the next section. So now let's explore the architecture behind this particular project implementation. and it is same like what we discussed in our previous video, that how to classify an image using Amazon Titan multimodal embedding to a particular category, right? That same format we are going to follow here. So here we will be having some training dataset related to bank statement. We will be having n number of images related to invoice category. We will be having n number of images related to email category. We will be having n number of images like that. For different category, we should be having ample amount of training images, right? Now what we will do, first we will resize those images to the compatible version what our Titan multimodal embedding model can accept. The width and height of those images we need to convert to that particular accepted values, right? And then we will pass via image embedding model and we will get its vector representation. We will store the vector representation of those different images in a Pinecone vector database or Pinecone index we can say, right? So here you can see, let's consider this is one entry in our Pinecone index. We are storing VB1. So VB1 is nothing but indicating the vector representation of this B1 bank statement image, right? So not only the vector representation will store, but we'll also store the category of this vector in a metadata. So whenever we store any entry in a Pinecone index, we can store certain metadata information as well. And here with this particular vector representation of B1 bank statement image, we are storing its category as well, that this particular vector is belonging to bank statement category. Following that same pattern, for this B2 image, VB2 is the vector representation, and for that the category bank statement will be storing. Similarly, following that same pattern for the invoice image I1, suppose the vector representation is VY1, along with that we will store the category invoices. Similarly, for this I2 invoice image, suppose the vector representation is VI2, along with that we will store the metadata information, the category, that is invoice. Okay. Similarly, for email, for this E1 image, suppose the vector representation is VE1, along with this particular vector store, we will also keep the metadata information that this VE1 is belonging to category email, like that. The vector representation as well as storing the category in the metadata information will be performing in the Pinecone vector DB. So this is part of our training process. Now in the testing process, what we will do, suppose we are getting some unknown image. First, we will get the vector representation of the image using Titan multimodal embedding, and then we will try to find out which vector in our Pinecone vector DB is having highest similarity, like cosine similarity, highest value will be getting with respect to this unknown vector. Okay, so that's what I have written here, that once we get the vector representation of the unknown image, we will try to perform cosine similarity, and nearest one similar item we will try to find out from this vector DB. And suppose the nearest vector for this unknown image, which is having highest cosine similarity, is this VE1. So for this VE1 vector, what is the category stored in the metadata? That is email. So we will conclude that this unknown image is also belonging to the email category, right? So the nearest vectors class will be the class for this unknown image. So this is our training and testing process, what we followed in our previous video as well. So let me show you the code quickly. So as a first step, what we are doing, we are installing Boto3 and Pinecone. These two modules will be needed, and now we need training and testing data. So testing data, earlier we have already seen that with these images we tested in our demo section, right? And we need training data set as well. So here for each category, considering bank statement, closing disclosure, email, invoice, social security card or W4 form, for each of these different classes we are having training data set as well. So if you see the bank statement folder, within that we are having 3 images. Let me just open. So here you can see this is one particular bank account statement. Here if I open another one, this is another bank account statement, and here we are having another bank account statement. Like that, for each possible classes we are having some training data set, right? So what we will do, we will perform image embedding on this training data set and will store its vector representation along with the class in our Pinecone vector DB, right? So this is installed. Now as part of the next step, we will download the training and testing dataset. Whatever we are showing in this particular folder structure, that is available in this particular URL as well. So we'll execute this particular curl command, and once the command is executed, here you will see that this particular doc classification sample zip file got downloaded, right? We will unzip that, and that way we'll be getting the training and testing dataset in a folder structure. So here the unzip is done. If I refresh, Here you can see that sample gallery, which is basically containing our training dataset, and the test gallery, which is basically containing our testing dataset, is available. Now here it is basically having the same code what we discussed earlier in our previous video, where we explored in detail how to perform image classification using Titan multimodal embedding. That is, here we are importing all the necessary modules. We are creating the Bedrock client using Goto3. We are importing Pinecone. We are using Pinecone API key. We are basically referring to this particular Pinecone index or vector store. So let me create that. So here I'll go to create, put that dimension. So for our Titan image embedding, the vector dimension is 1024. So I'll create the index with 1024 dimension. So here this particular index got created, right? And here we are importing the image related modules because we need to read the images and resize it. The maximum allowed size with respect to height and width is 2048. So this particular function is doing that particular activity. It is resizing the image to that particular height and width if the image size exceeds, and it is converting the image to its vector representation. And here in this particular function we are performing the image embedding. You can explore my previous video if you want to get the line by line explanation. And now here this particular function is basically helping us in listing all the file names belonging to a specific directory. And now we will go directory by directory and will perform the embedding and store in Pinecone DB along with its class. So here you can see, let's consider the image category bank statement, right? So here in our bank statement we are having three different images. So first we are getting the list of all the images stored in this particular directory, right? It will give us the name in this particular variable. We are iterating and we are storing. After converting the image embedding, we are storing in this list, in the vectors list. Okay, and here you can see not only the vector representation of bank statement category we are storing, but we are storing also the metadata that for this image the category is bank statement. Like that way we are going to the next particular image directory, that is closing disclosure. And here let me just copy this thing. Here I will again define that empty variable vectors, and again we will get all the file names of the images stored in closing disclosure, this particular folder, and will perform here image embedding for those closing disclosure images and will store with closing disclosure class. Following that same pattern for the email class as well, will follow that. Only changes, metadata will store now emails. Okay, right? And then invoices, for that here metadata will be invoices, and for social security card the metadata information is SS card. Okay, right? And the last class is W4 form. So for that again from this folder first we will get all the image names, we will get its vector representation, and we will store with the metadata that category is W4 and will store in our Pinecone index. So let me quickly run this particular code. It will basically iterate in all these training folders and it will store the vector representation in this Pinecone vector store. So let it get executed, and then once the execution is done we can basically perform index.query, and here we can pass the vector representation of a test dataset. So here you can see that sample gallery we basically used for training, and in the test gallery here we are having some unknown images, like here Atlantic bank statement.png. So this particular png is unknown to our model actually, but it will try to find out the nearest vector using cosine similarity, and once we get that we will try to get the metadata information from that nearest image which is stored in our Pinecone, and for that the category will be extracting. So here Atlanta bank statement image, let me just show you. You will find that this is nothing but a bank statement image. So here the image got downloaded, and here if I open this is nothing but a bank statement category, right? So I will just execute this particular cell, and here it will try to find out the nearest similar image what is stored, and for that whatever class is there that it will return us, right? So this is a typical flow what we followed in our previous video as well for image classification. And now the question is how we can perform this particular testing in near real time, right? So for that, obviously, as we discussed here in the demo section, that whenever a file will be getting landed, the pipeline should able to detect its class and it will put in a respective folder in our this particular output bucket and delete the image from our landing layer as well. So how we are doing that? For that, obviously, we are going to take help of Lambda function. So this is a simple architecture. Once the client, that is once the user or from some source, the file will be getting landed in our S3 bucket, what will happen? It will trigger a Lambda function, and the Lambda function will execute this particular command. Only it need to execute this particular section, that is image.query, and it need to find out the nearest vector, right, which is having highest cosine similarity, right? So for that, first what it will do, for that image, it will first get the vector representation from the Titan embedding model, and then it will apply cosine similarity to find out the most similar image, and then once it detects its class, it will basically move that particular image from this input directory or input bucket to the output bucket in that specific directory location, right? So Lambda function we can easily use to implement this particular flow in real time. So let me show you that particular Lambda function implementation now. So before that, let me just delete these particular classes so that I can show you a fresh demo. So here currently our input and output both directories are empty, and now let's see the Lambda code. So this particular classifier in real time code is available in this particular GitHub repo. I'll be sharing this particular repo in the description box. You can follow the code from there. So as a requirements.txt, we need two things. One is Boto3, another one is Pinecone. Boto3 is required for creating Bedrock client. Pinecone is required for performing this particular index.query. And apart from that, one more module is needed, that is Pillow. Pillow will be helping in image resizing or reading the image from the input S3 location. So here I have basically mentioned only two modules, Pillow and Pinecone client, because these are not available in our Lambda runtime. Apart from that, Boto3 is by default available, so we no need that, right? And then here, let's go through our actual Lambda function. So what this Lambda function is doing, here we have imported all the necessary modules. Here we are defining the maximum image height and width, what is acceptable. We are creating the Pinecone index pointing to the particular index where our training dataset embeddings are available. That is basically this particular one, gallery store. So here if I refresh, here you can see that in this particular Pinecone index, all our training dataset along with the metadata information which will contain the category that is available, right? So the same gallery store, here we are creating index and destination bucket. So for our case, from the input directory, the Lambda will be triggered and it should copy those images in a specific directory in this particular classified bucket using LLM in this particular bucket, right? So this is our destination bucket that we have configured. Here we are creating the Bedrock runtime using Boto3, and S3 client also we are creating using Boto3. And here we have kept the same image embedding function, which is performing image embedding for our unknown class, which is getting landed in landing directory. And this is our main Lambda handler. We are reading the bucket information and the key what landed in our input directory from the event, which is triggering our Lambda function, right? We are getting the S3 object, we are reading that, and we are opening using Pillow module. We are reading that particular image, we are resizing that particular image to its maximum height and width, what our Titan embedding v1 model will accept. We are getting the bytes representation of it, and that's what we have done here, convert the resized image to bytes, and then for that byte image we are getting its vector representation using Titan embedding, right? Once we get the vector representation, we are performing the same thing what we have done here, image.query, and then using this kind of way we can get the nearest similar images class, right? So that we are getting, and we are printing the image classified as image class, and then we need to copy input image to the output directory which is belonging to this image class, right? So that we are performing new key. So the file name we are keeping the same, only the directory will be belonging to the image class, and we are performing S3 copy object from the input to the output destination bucket. And then once the copy is done, we can delete the image from the input directory or input folder, right? So that we are doing, and we are printing the file is moved, and if the exception is raised, it will be basically handled in this except block. So I hope the rough Lambda code is clear to you. Now we will basically create a Docker image out of it. So here we are having the Docker file for it. So from Python ECR Lambda Python 3.12, we are copying the requirements.txt. First we need to install that Pillow and Pinecone client. So that we are doing using pip install requirements, and we'll also copy the Lambda function, and then we need to execute Lambda function.lambda handler, right? So this is a typical ECR based Lambda function how we create, that we have followed. And here we are having a GitHub workflow as well. So what this workflow is doing, whenever there is any change in this particular repository on push event, this particular flow will be triggered. It is nothing but pushing that particular new image in our ECR repository. So the ECR repo should be having the name LLM ECR. So let me create that. Elastic container registry I'll be going, and then here I will go to the repository section. I'll create a repository. So in our case, LLM ECR is the repo name, and I'll create this repository. Okay, right? So here what we are doing, first we are logging in to our AWS using the credential. We are logging in ECR, and we are building the Docker image, right? Repository name here we have configured, and Docker build platform is Linux AMD 64, which is default to our AWS Lambda. For that, we are creating the Docker image, and in the next step, we are pushing that image in this particular repository. So currently our repository is empty. So what I can do to trigger this particular workflow, maybe I will just do a dummy change. I'll just hit a new line and I'll commit the changes. Okay. So here new workflow should be triggered, and here you can see. So here the job is getting started. So what it will do, it will basically create a Docker file or Docker image out of our code, and it will push in this LLM ECR repository. And using that particular image, we'll be creating our Lambda function now. So here I will go to Lambda. And here I'll create the function. From container image I want to create the function name, I can put demo real-time classifier YT, right? Here the container image we need to provide. So container image will be getting from here once our this particular CI/CD process will be completing. So currently here you can see it is pushing the image. So here it is running its last step. So hopefully the image will be pushed. So here, yeah, the image is this one. We'll be copying the URI and we'll be pasting here, right? Container image URI we have pasted, and then here we'll create the function out of it. So here successfully Lambda got created. I need to do some changes, like for example in the configuration section, here I need to increase the timeout also. 5 minutes 3 seconds maybe let me keep, and the image can be having a good volume. So here I can increase the storage size to some high value, right? And existing role also you need to update, so that I will do. So here I'll go to permission section, and in the role I need to provide bedrock access and S3 access, because Lambda will be using the bedrock for getting the vector representation of the image whatever is getting landed, and to read the image from this S3 location Lambda need S3 access as well. So here I'll go to add permission, attach policy. Here I will search bedrock, and apart from that I will provide S3 access also. You can fine tune the access when you are moving to production. As of now for this demo it is fine. So here these policies got added, and we need to add the trigger also now. So whenever the data will be getting landed in this particular bucket, we need to trigger our Lambda function. I'll acknowledge this and I'll add it, right? So with this our framework is ready, and here it is showing some error. So let me just check whether this S3 bucket is already having some trigger or not. Yeah, it is already having some trigger which I used earlier to show you the demo. So I'll delete that, and once the existing trigger is deleted, I can add this thing, and yeah, here you can see that this particular lambda will be getting triggered from this S3 location, right? Whenever file will be landed in this particular bucket, right? So it's time to test it out. So I'll go to objects, and here what I will do, from this testing section I'll upload a sample image. Maybe let's consider this particular test4. So let's see the category of test4 actually. So test4, here after going through this particular image manually, we can understand that this is nothing but a invoice category, right? So these kind of images we have not trained it, but we can hope that whatever training images we kept for invoices, with that this particular image will find high similarity, and that way it will be classified into the invoice class. So here we have uploaded, and let's see. So here from this input directory, the image got already deleted, and if I refresh here, hopefully one particular folder should be created with invoice category, and there our test4 image should be available. So here you can see the invoices folder got created, within which our test4.tif image came. That means the classification is performed properly. Now let me show you another example. For example, let's consider this particular thing. This is nothing but an email, as you can clearly see. Let me just zoom this out a little bit, show you properly. As here you can see, this is an email type. So let's upload this particular image. Upload failed. So let's refresh. What happened, I'm not sure. Okay, internet went away. Let me just connect it. So here I will upload this test3 image. So here the image is uploaded. Now soon we should see a new folder with emails, and then there test3.tif image should be available, and from our input location the image should be deleted also, right? So here this lambda function and this pipeline is performing that particular activity in real time, right? And the steps are very simple. All we are doing is, as part of step 1, again I am reiterating here in the lambda function, if you see, as part of the step 1, we are getting the information that this is our input bucket, this is the file what got landed. We are reading that particular image, we are resizing it, we are getting its byte representation, we are converting to vector, and then we are trying to find out the most similar image what is stored in Pinecone, and from that we are trying to find out the category of that most similar image, and we are classifying this unknown image what got landed to that same category, right? And we are moving from this input S3 location to the output S3 location, and we are deleting that image from the input S3 location. So this is a simple lambda function which can be used to classify documents in near real time, right? I hope you understood this. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.